I was talking to you about this. We'll continue with the next lesson. So, previously in that class, listen now, we're continuing. Listen. So, the next lesson is actually really easy compared to what we just did. It only has one extra idea, which I'll explain now. And then we're nearly finished calculus. Then there's only one lesson left in calculus, and then we're on to probability. So, you notice that one problem we have is we don't know what the C is. So, just to get us warmed up, if everybody can integrate this function, please. We'll say 3x squared plus 2x plus 1. And we'll call the answer capital F. Yeah. Okay, so what do we get here for capital? Yeah, we get x cubed plus... Yeah, plus C. Now, one way we can get rid of the C, although we don't know what fx is, we can actually know, we can compare fx at different values. So for example, if I calculate fb, I get this, b cubed plus b squared plus b plus c. And if I calculate fa, I can get a cubed, If I minus these two values, the c's cancel, and I can get an answer using a and b, the numbers that I have. In other words, what I'm saying is, we can kind of get rid of the c if we look at the value between two different places. In other words, imagine I have something like this, x squared dx, and I want to know what is the difference between 0 and 1. The way I would write that is by putting a 0 here and a 1 here. What I do is I integrate, that's x cubed over 3 plus 0, and then I put in 1, I put in 0, and then I minus them. So I'll get 1 over 3 plus c minus 0 over 3 plus c. What do I get here? 1 over 3. In fact, because the c always cancels, for these types of problems, I don't need the c. So in other words, for problems where we have what's called the limits, if I want to know how the f changes between two values, I don't need the c. So I'll use small f as the question, and then big F as the answer. The answer will be big F B minus A. And we call this a definite integration. Because it has definite values. Let's have a look at some examples, but this is the concept. Yep. Can I scroll down a little bit to here? Okay, so here's my example. That's something you might get. Let's integrate from 2 to 3 1 over x dx. So 1 over x becomes log x, and then I need to put in the two values, 2 and 3. So first I put in the 3, then I put in the 2, and then I minus. What's log 3 minus log 2? It's log...
3 over 2.
No, 3 over 2. Can you see? Yeah. Simple. simple continuation from the previous lesson. So let's have a look at another example now. I'll let you try this one. Integrate from 0 to 1 root x, please. Try this one. Okay, some of you should have answers now. What is it? I think so, yeah. So this is integrate from 0 to 1, x power a half. That will be x power 3 over 2 over 3 over 2 from 0 to 1. Put in the 1. Put in the 0. We don't actually care about the 0 because no value. So this will be 1 over 3 over 2, which is 2 over 3, like that. Yeah? Okay, let me give you a harder one now. Zoom out, like this. And here? Here? Here. Okay. Can I go to like here to try this one? Let's see. Hang in there, Sean. Hang in there. -1, no, 0 to 2 pi I haven't written anything yet. 0 to 2 pi sine x plus cos x dx. Can you see that? Sin x plus cos x. Got an answer? What did you get? No. Why do you sound surprised? That is correct. Hopefully you'll get the same answer. Okay. What answer did you get? Yeah. Right. Yeah. So, are we ready to see this? Eric, ready? Yeah? Okay, so when we integrate sine x, what do we get? Yeah. And cos x? And Did I? That's outrageous. Are you sure? Show me proof. Show me proof. Did I?
What?
That's disgusting.
That's why I got confused. Okay.
Do you know what the problem is? I didn't have enough to eat for lunch. Guys, Jerry, you need to be more. You should be saying, teacher, do you feel okay? You made a mistake. Are you okay, teacher? That's what you should say. Thank you, Jerry. Thank you. I'll try to do my best for you. Okay, if you can just go to the table I gave you. Do you see number 3, where I say cos x? That should be sin x, not minus sin x. Can you change this back to plus sin x? So number 3 on the table, the cos x should be sin x when you integrate. No, sin x is minus cos. Cos is plus sin. Did you all get that?
Yes.
Huh? Oh, that's a bit difficult. It's in semester 2. We will do it. Yeah, but funny enough, the antiderivative of tangent is actually much harder. Yeah. Okay, did you fix that?
Yeah.
Yeah. So that should be a plus then. Yeah. Now, in the exam, you actually have this table in the exam. So it's, you can see this table in the exam in the formula book. So you can always check these things. Yeah. Okay, so now we have to put in 0 and 2 pi. So first we put in 2 pi. We got minus cos 2 pi plus sine 2 pi. And then minus, and we put in 0. Now if we hit this in on the calculator, we get 0, 0, 0 and 0. So the answer is 0 here. Well, in total you'll get 0. There's minus 1s in there. hang on. Shh. This one is 0. I can do this. This one is 0. Minus 1. Minus 1. So you got minus 1 minus minus 1. I know, it's still 0. They're picky. They're picky. They. Sitting over there. Alright, one more example of this now. Try this. Try this, please. Try this one, please. What is this? I want you to try this. Got the answer?
Zero.
Yeah, 0. It should work out to be 0 because when you integrate here, you get, let's see, what do you get? X squared over 2 plus x4 over 4 plus x5, 6 over 6. Now the reason I can do this in my head quickly, and the reason I know it's 0, because when I put the 2 in, or the minus 2, I actually get the same answer because of the powers. So it means when I minus them, they'll cancel to 0. So I knew the answer was going to be 0. So actually at the very, very beginning when I wrote the question, I knew it was 0 because of two things. Firstly, these are the same but opposite in sign. That was the first thing. And secondly, all these powers here are odd, which means when they integrate they become even. You know. So I mean, I didn't expect you to see that. But when you do lots of these, you see things like this that you know the answer maybe will be 0. Now that won't happen in the exam, and even if it does happen in the exam, they still need to see all the steps. So the next step here will be to put in 2, and then after that, did you go out that door and come in that door? Put in 2, sub 2, and then sub minus 2, and then minus them. But I know these two answers will be the same in this example here. Yeah. This is a common section A question as well in the exam. They ask you to calculate things like this. And what's nice, if you have this calculator, and you all check?
It's like advertising for that.
It is actually like advertisement, yeah. Yeah, I should get them to sponsor my YouTube channel or something. This lesson brought to you by Casio 991. If you have the Casio 991 or similar, if you look at the calculator, have a look at it, you might see an integration button somewhere in the top left. Can you look for that?
No.
Can I see your calculator? Turns? No.
No.
Yes. Yes.
Yes.
Did you find the button?
No.
No. I'll show you how now. Did you see it looks like the integrate symbol. That doesn't have it, does it? Yeah? Drew, you have the graphing calculator, don't you? Does it have an integrate function? It must do. Could you type something like this problem into the calculator, your graphing one? Yeah, you know how to? Watch. So here you see you have an integrate button. Some of you do. Minus 2, and then inside here you can type the function. So what was my question? It was x. So alpha x plus alpha x cubed plus alpha x power 5 equals, and it will calculate, and we get 0 here. Yep. So in the exam, those students with this calculator have an advantage. They can check if they got the right answer. If they got the wrong answer, they go back and fix it. This is one of the many reasons I recommend this calculator. I have a reason for it, you know. This is one of the reasons. For this question in the exam, you can check your answer. You can know if you got it right, and so you know you have full marks. Yeah? How many people actually have this function on their calculator? So Monica, no. Yes? No. On the back? 1, 2, 3? That's anyways, look, you can use whatever calculator you want, but you know, this is the, I think, most helpful one for the exam. Alright? Let me give you some questions to try now for this. In question 1, I want you to do 1x. And in question 2, I want you to do O to T. Well, sorry, what I mean is like straight down. Yeah, so O, P, Q, or S, T. Yeah, you can start these now for a few minutes.